Okay, so what we're going to be doing here is using the new input system and Unity's mid-level API for networking to get some character control and character movement. So the first thing we're going to do is go and add in the new input system. So we're going to go to Package Manager, open up that, switch to Unity Registry, and we're going to search for input system. And we're going to install that. And we'll let that run, and it's probably going to ask us to restart Unity, and we'll let that happen. And our first steps, what we're going to do is build a basic scene and get our character moving around on the scene. So here we've got the option to go through and restart. So let's just do that. So here we've got Unity up and running. I've got this initial sample scene. What we're just going to do is let's just go and add a plane, and we'll just make it 3 by 3. Actually, don't even need to worry about that one because it is a plane. So we've got a character on there. Let's just move that camera up a little bit and back, and let's just rotate it down, just so we can see what's going on. So we've got our character. I'm just going to quickly save that scene. Yep, it's still on there. That's all good. And we're now going to go and create our character. So I'm just going to add in a capsule. Let's call it player. Let's drag this guy up a little bit. Let's just bring them maybe 1.5 up. And we're going to add a character controller to them. And we'll just leave that with its default setting. Next, we want to go and add our player input. So from add component, we're going to go and type in player input and choose that option. I will just minimize some of these so we can see them. Add component, player input, and by default it's saying, hey, we've got no actions. So I'm just going to use the default ones. Going to hit the create button. It comes up. I should create some folders for calling the actions. I'm going to make sure I don't have any information there, so we're just going to call this player controls input actions. And if I go back to there, we can actually double click on this, and we can actually see our player input actions. So by default, left stick is used for gamepad, WASD. It has all the default sort of inputs, and it's got a look and a fire. So the look is by default mapped to either the mouse under the pointer or the right stick for gamepad, and move is on our left stick. So we've got those default controls, which is pretty cool. I am also going to generate a C# class. If you're just doing it for the new input system, you don't really need to worry about this, but we want to have this for when we're using the mid-level API, because we need to do what's called some callback contexts to link these together. So I'm going to generate the C# class, hit apply, and the reason why I didn't want to have space in this file name is just so that when it generates this C# script with some JSON in it for the controls, it has, a proper class name that is easy for us to reference later on. Okay, let's go back to our player. We're now just going to add those input actions onto the player. So I've just dragged our input actions onto where it says actions here. We're just going to leave default scheme to any. We can leave auto switch, and we don't want to attach a camera, because what we can do is actually attach a camera to the player and it will default to that. So what would be quite nice is if when we hit the play button, this actually did anything. But sadly, just adding those controls doesn't automatically assign them to us. We still need to go and add a script. So let's just hide these away for us. And we're going to make a new script. And let's call this Player Movement Manager. So that's what it's going to do. And I'm going to attach that to the player. No, that's not the player, that's the player. So I want to attach my Player Movement Manager, and that's where we're going to go and add our code in to get this to work. So let's go in your favorite editor, open up the script. So here, in all the best, here's one I prepared earlier. So we need to add in, using the Unity engine dot input system to bring in the new input system. And we also need to have our character controller. And give that a variable name. I'm going to want a 2D vector for my movement input. So this is when I'm pressing the left and right mouse button, not left and right mouse button, like WAS or D, the arrow keys, or using the left stick on a keypad. And I'm also going to have a speed variable for how fast I want to move. And let's just set that to 3. Okay. So I'm going to actually make this character controller public because I want to link this up externally. Okay. Now, on start, so this is when it's going to configure. We're just going to set it up here and we'll change this later on when we actually get our main game up and running. So I want to use the character controller, get component of type character controller, and link it up. So this is going to happen at runtime. Not ideal, but it works. And let's go and set some colors for our player. So just make a variable. Render color is assigned to get component, and I just want to get the renderer. So these are sort of options, not exactly essential. Render color dot get the material of that renderer dot set the color, and we pass it underscore color with a capital C, and we choose our color. Okay, so let's just switch back to Unity. Obviously we haven't actually added any movements, but let's just check that's actually working. And sweet, we've got a little blue character there. So we can now go back into here. So what we now want to do is go and add some code for handling our inputs. And what we want to do here is go and link this up to our MLAPI actions. So if we look at over here, we want to link it up, not so much to this, but to the C# version that we've got. So the reason why we created this file is so that we can actually access it through our scripting. So what we're going to have is make a private variable. What did I call it? Player controls. I'll make that variable just called controls. And what we're then going to do is basically create a sort of constructor for this that will basically generate one. If it's there, use that one. If it doesn't exist, we'll create a new one. So we'll have private player controls, capital C for this time. Okay, and we're going to get if controls is not equal to null. So if it exists, return it. Otherwise, return new player controls. So essentially, every time we run this, we're going to check to see if it exists. If it does exist, return the existing one. If it doesn't, create a new set of those controls. So this is a bit of foreshadowing for when we're dealing with the MLAPI layer, so that every time we create a new player, it'll be sort of by default null. It'll go and create a new set of controls for that player. Because one of the things with this new input system is this one set of player controls will be sort of handled essentially on one client. So it can be reused over and over on that client or single PC. Because the new input system does really nice local multiplayer. So now we want to think about dealing with some movement. So we've got this vector2 movement input. So that's going to handle us moving around. So we're going to make a couple of little functions to call this. And we want to have one that can basically set that movement. So whenever we press something on the keyboard, we want to change that value. So we're just going to call this set movement. And it's going to be a vector 2. And it's going to be our input vector. And we want to just use a lambda function to forward that. So movement input is assigned to the contents of input vector. So whatever movement we detect, it is going to assign it to this value here. We're going to add our callback context to go every time we actually detect some movement being pressed. We're going to tell it to go and run this in a little section later. So private void, we're also going to cancel movement. This takes no arguments. Once again, lambda function, movement input is assigned to vector2.0. So essentially, if we've let go of the button, we're going to point back to 0. So that's our first little steps there. Okay, so we've cancelled our movement. Now what we need to do is go and add some callback context. We're going to do this in the start function. So we're going to have controls dot get the player that's linked to that control asset. It's got a move function. The reason why we know that is if we look on all of our player controls, we've got move, look, and fire. We can actually add all our own ones in here, but we're not going to in this point. How do I delete that? Right click, delete. So move, look, fire, obviously we can add all our own ones in there, but now we know that we can just dot move and get, it'll detect that movement. So, makes our life a lot easier, rather than having to code in every single user input. So dot, or keyboard input, or controller input, if it's been performed, add on a context, and use the lambda function, and so whenever that happens, we're going to run set movement and we're going to pass it whatever context it was, get the value from it, and work out what type it is we know this one's going to be a vector 2, and send that off. And now we need to add one for our player. If they move, if we cancel the move, so if we let go of the button, get our context, or callback context, and we want to cancel the movement there. Finally, we need to actually move the player. So let's actually change that from an update to a fixed update. So we need to create a 3D vector. So a movement vector, vector 3, and it's going to take 3 arguments, X, Y, and Z, and for moving around on our different axes. So if we look, remember, our X is going to be across, Y is our vertical, so we don't actually want to do any vertical, and Z along, like forward and back. So we've got our new vector. Thankfully, we've taken our input vector, whatever was inputted, and assigned it to this movement input. So we can now just do movement input.x. Okay, we don't want to move up vertically, so we're going to have nothing on the y-axis. Movement input.y to move us essentially on the z-axis. So remember, these x and y's are to do with our position on the board, where we're moving to, and the x and y is in relation to the inputs we're giving on our controller or our keyboard. So X is basically A and D, Y is W and S, or forward and back on the left stick, left and right on the left stick. Okay, so once we've got our vector, we actually want to move it. So we're just going to get our character controller, use the move function on that, and we're going to pass it our move vector, multiply it by the speed, and let's just make sure we sort of hold it by sort of time, and let's go and have a look at how this works. Now what we also need to do is basically have a way of enabling and disabling those controls. So we're going to have just private void on enable, and let's just use it as a lambda function. So essentially, when we enable this, we will enable the controls, and on disable, we will disable them. So let's switch back to Unity. Let's let that recompile. If we now hit our play button, and we can now move our character around. Let's just do a very lazy camera attached to that. Let's just, we can have our own camera scripts, but let's just go and link it onto our player. So let's just take that as 0. Let's maybe make that a 5, so it's up. Let's drag it back, maybe 3, maybe -3, -5. Let's angle it down 30. That's looking pretty good. Let's just test that again. Cool. We've got our little camera, and what we'll note is with the new input system, it will automatically switch to that camera. Right, so here's our default view. Boom, we switch over. So main camera. So let's turn this into a prefab just by dragging it down. So now we've got our player prefab, which we can have all good and ready to use. Okay, so now we've got our player moving around on the screen. We need to go and add in the MLAPI networking. So as of June 2021, this is still not actually available directly through the package manager. So we're going to have to add it through a git URL. So you're going to need to make sure you've got git installed in the first place. So, if you just need to install that, search out for git, download it, install it, make sure you restart your computer. Now, for you Google Unity MLAPI install, you'll get the link and a bunch of instructions. There's this link here that we need to copy, and we're going to add that as a URL. Click add, and it will take a little bit of time to go and add this new git package. And as we can see now, it's compiled most of it, and this brings in a whole bunch of pretty cool and awesome networking tools. So once that's installed, we're going to go back and we're going to add a few things. So first up, we're going to add an empty game object and call it Network Manager. And we're going to add a component. And if we scroll down, we can go to MLAPI, and we're going to add a Network Manager object. Now you see by default, it says there's no transport mode. We're just going to select UNet Transport. And by default, there's network prefabs. It's got a list empty. We're actually going to delete the player from the scene, but make sure you've got them as a player prefab first. And on our network manager, we're just going to drag our player. Actually, we can't drag, we've got to do plus. Get a prefab, choose it from our assets, use the player, and make sure it's ticked for default player prefab, so that when the network manager starts, like as a host, we're able to actually go and create that. And we can actually now just do a really quick test just by hitting the play button. Okay, looks like nothing's happening, so we're just going to select our network manager, scroll down, and we're just going to hit start host, and we can see it now actually goes and generates our little player character. And hey, they can move around, which is all pretty cool. So we've got a host created. Obviously we need to do a few different builds to be able to go in and actually start, stop, and edit those. So we're going to add a little menu on the top of this. So what we're going to do is just a bit of basic UI. So let's just go create UI. I'm just going to use some default buttons. You can use whatever you want. We're going to have one button for host and another button for client. I'm just going to modify the text that's on each of these. So my first one is going to be, actually, no, that host is going to create game, and that basically sets up essentially a server and a client. So we're just going to use a few little descriptive messages here. Let's get that nice and centered. Let's just change those host properties. Should have done this for both of them before. Make it 250 wide, 30 high. Yep, that's fine. And let's do it at 15 up. On the client, let's just move that one down 15. And let's still make it 250 wide. That one's text for the client. That's essentially join game. And we're going to create a client. Oh, my keyboard is nearly dead in terms of battery, but we should have enough to get through. So I've got my two little buttons here. Let's go and change our background. I just want to have a nice sort of solid color on this. Oh, my teardropper is off the other side. Yep, let's just have black background. And we want to change it from skybox to a solid color, so we can just see our environment and our level behind us. That's all we sort of need. Okay, we don't have any actions on the buttons yet. Now if I actually click the play on this, we're going to get an error saying we're trying to use the old input class. So what we need to go through and do is on the event system, replace that with the new user input module. So this new system can basically handle our inputs. Okay. We also get an error saying the MLAPI player object doesn't have a network object. We'll deal with that at a later stage, usually in the next video. So we've got our first canvas. Okay, let's rename that to Canvas Network, because that's what our goal is there. And I'm actually going to add a second canvas, which is going to have player info on it. So we can put this in a lot of different places. I'm just going to include it here, just for this example, essentially. Let's add a UI, bit of text onto that, leave it as just text. By default, we're going to have it saying no role. And where is that text gone? Okay, it's just in the middle there. Let's just drag it right up the top of a canvas, and let's center align those. And we'll just make that height 50, and let's actually make that text also nice and big. So we've now got our no role piece of text. So we've got no role that appears. Let's just go back onto our network manager. Let's start the host. And what our goal is going to be is we're going to get it, when we click one of these buttons, it's going to change this bit of text. So for that, we're going to need to include a script. So let me just hide away these other bits I don't need to worry about. I'm going to print another empty, and I'm going to call it Game Manager. It's going to handle all my game details. And I'm going to put a script onto this. So let's just create a new script. And we need a bit of a description. So essentially this is going to be handling just this front end. So let's call it maybe UI Network Connect, something like that. And let's just attach that to our game manager. Okay, so we've got that. And let's open this up in your editor of choice. So there's going to be a few things we're going to need to use. So I need to, as I'm going to be manipulating the UI, I need to get the Unity engine .ui loaded. But most importantly, I need to use the MLAPI packages. So I've got a few different bits of text I'm going to want to modify. So I'm just going to make some public variables to make it easy to access these. Obviously, there are always other and better ways to handle this. So I've got my text for the user role, which at the moment is just showing user role or no role at this point. And then I've got my canvas, which is that network canvas, which holds all of that other information. Now, what I want to do is don't have to worry about doing anything on start or update. I can actually just sort of clear out that. We'll leave the start there just in case we need it. Now, I want to have some functions that I can run when my buttons are clicked. So I want a public void, and I want a start host function. And what this needs to do is I need to get the network manager. It's a singleton because we're only going to have one network manager, and run the start host function. And I'm also going to set the user role text to be the word host. And I want to get rid of that menu. So I'm going to get connect menu, get its game object, set it to be active, and set that to be false. So we're disabling that. Okay, got one of those. Okay, once again, not efficient code, but hey, we're just working out, making sure we get something to run. And we might later want to actually have more custom options for setting up our client and our server. So they're probably going to be more useful later on. So I want to start the server. I want to actually change that message to server. So server will just start the game up, won't actually have you playing. Essentially it becomes sort of a headless or dedicated server. And we need to start the client and have that text changed to client. So let's switch back. And let's see what happens. So we've got the game playing. Okay, we haven't got any actions. So what we actually need to have happen is link these up. So let's go into our game manager. We've got our user role none. So let's go, got a few different texts. That's not that helpful. We probably should have renamed them, but I know it's going to be this one. So that is the one I'm going to want to link to here. Always good to have better variable names. And the connect menu, thankfully I know that's the canvas network. So let's try again. Create game. Oh, no. So as a reminder, we've got our text and our network canvas linked up to our Visual Studio work. So this here will basically update to host, client, and server. The client and server will generally work okay. When we try and start the host actually through this button, it's probably not going to work as well as we'd hoped, mostly because we haven't got all the networking actually set up at this point. So let's get back into Unity and link up these buttons. So on our host button, we're going to add an on-click event. We want to grab from the scene the game manager, and we're going to run the start host function that we've got there. Same thing for the client. We can actually also just drag in the game manager from the hierarchy. UI network component, but this time we want to start a client. We'll just save that, hit play. Now, see if we hit the create game, still the no role appears. We've actually run into the odd little error. We can, if we hit the join game, we do actually get a little client picture, but we haven't actually turned our player object into a network object that can sort of be managed there. We actually go to our network manager. There is somewhere in here for our debug level. Okay, and here it is under log level. We can flick it to developer, which is sort of more useful. You know, we can see what our warnings are and errors that are popping up. So our next step is going to be adding the network objects to our player prefab and modifying that. So our main job here is going to be modifying our player object. So let's just minimize a few things we don't sort of need to see. So we've got a few things we need to go and add. We need to add a network object as well as a network transform. So if we go into the MLAPI, we're going to add a network object, and we're also going to add a network transform. So these are our two new items that we've included. So what we need to make sure about is on our network transform, we've got a few details, sort of how we want to have it extrapolating the positions and linking up with the server. Most of those we can leave as they are. And on our network object, we've got it linked up to our player. that's generally going to be okay as is. So that's most of our first settings done. Let's see what happens when we run it now. So at least when we create a game, because it's now a network object, we actually now still have our host. But we're still going to run into some problems when we try and get our second character involved for the join a game. So let's just do a quick little build and run and see what happens. Just make a little builds folder. So let's go on the build, let's create the game. So we've got our little host. And if in our little debug window, let's try and join the game. And let's look on that scene, let's try and get that plane back. Okay, so we've got our client moving. But we've got a bit of craziness happening, so we've got something going on with our netcode. And we've got no sort of collision detection. So we're getting there, but we're not quite right. So now we need to go and modify our player movement manager. This is going to become sort of our networked player movement manager. So actually let's just open that back up. So most of it is going to stay the same. But obviously we also need to use MLAPI, and we might need a few other bits of information, but let's just start with what we have here. So some of these aren't always required. But so this is probably not needed here to serialize some of these fields, but we just need to make sure that these can be sort of treated independently. So we've already got our player controls, that stays all the same. Our biggest change is our player movement is not a mono behavior, it is a network behavior, which actually extends mono behavior. So it knows all the stuff that mono behavior needs to know, already knows how to do. Now, our start method is going to change. We're not going to use the start method. We're going to use the network start method, but we're going to override the existing one, and it is now network start rather than just start. So public override void network start, and we want to actually base, so get the original one and run the default network start first. We get our character controller. Now we've got a few other different little things we want to sort of check. So if we are not, or if we are the local player, this is something to do with the netcode. We want to do a few different things. So what we're going to do is actually just have our rendering color to be blue if we are the local player, and let's actually just modify it so that we are red if we're not. So essentially you will always be blue, everybody else will be red. Now we need to, if we are the local player, enable our controls. If it is not the local player, we do not want to have it enabled. So this basically just means that we each get our own set of inputs that are managed independently. Our controls there, they stay the same. Scroll down, we've still got our movement and a fixed update. We've just got one little change here. If we are not the local player. We just want to skip the update. So we only want the updates to run if we are the local player. This is all sort of client-based networking. It's not the greatest for accuracy, but it suits our purpose and gets us up and running. Okay, so now we're back in. We're just going to rebuild and get the player up and running. And once that's built, we're going to run it locally. And I'm going to create the game on the local one, so we can see that's the host, and we're going to join the game. We've got our client, who is now blue. They did spawn over top of each other, so we probably should do some random spawning locations. So we can see I'm blue. So it's a bit harder to sort of see what's going on. Do have a little bit of a problem in the fact that the cameras are actually sort of hooked up, but that's other things we can sort of deal with, so that both cameras are currently actually attached to the client. But we do have independent movement. So ways we can just debug and just take care of that initially. Let's just remove that camera from the player. We'll just go back to the scene, and we're just going to run everything essentially through that top view scene. So let's just go and do a rebuild. Now, if we used symlinks, this would make this a lot easier. So let's just hit the play button. Oh, we probably need to close that original one. Probably going to have to rebuild now. Yep.